Hello and welcome back, everybody. Tonight we're flying this wonderful Delta SkyTeam livery 737-800 here out of Fort Lauderdale to Tampa, Florida. Yeah, please follow along, enjoy this short flight, and I'm gonna talk you through it, how we would do things in the real airline world. I am myself a Boeing 757 pilot, and I fly this as my main job. So maybe I can tell you a little bit here about aviation. So stick around and enjoy the show. So this is the 737 here from X-Plane with a couple of add-ons and with the beautiful Delta SkyTeam livery. It's looking really nice in my opinion. We're going to head over to the flight deck here in a second. But yeah, check it out. It's not too bad, I would have to say. We are here at the Delta terminal, Delta 3 in Fort Lauderdale, and I'm just going to prepare the flight plan, figure out how much fuel we are going to need, and create a route from Fort Lauderdale to Tampa. I'm using Simbri for this. Basically, it's a free tool you can use to generate flight plans, and they have a database with many different aircrafts, as for example the 737-800. So this comes in really handy if you don't have access to any kind of performance or flight planning tools. Okay, welcome to the flight deck of the 737-800, and I just created our flight plan to Tampa, and I got the fuel figures. So block fuel, we need 5,108 kilograms. We are usually rounding it up to 5.2, but we can take some extra for unforeseen delays, etc., which I will not expect today. So I'm just gonna fill in 5.3 tons here in this aircraft. Currently we have around 1,800 in each tank, so 3.6 tons. So I need like mental math, 1.5 to fill up our tanks to comply with our minimum fuel to depart out of here. Okay, I somewhat have figured it out. So payload, you can see, is 11.2 tons rounded up. Zero fuel weight 54.2, and we would round that one up, so it's 54.3. Actually, fuel required 5.3, so that gives us a takeoff weight of 59.3. That is in accordance with my flight plan, and you can see the takeoff CG is 23.8, and the zero fuel CG also 23.8. Let's check the diagram. So yeah, they are all within limits. This line is here for the maximum zero fuel weight, and we are way below that. As you can see, if you would extend that line over here, we are I don't know, at 54.3 like I previously said, and our takeoff mass at 59.3, which is also way below the maximum takeoff mass. This is actually maximum landing weight. This here is the maximum takeoff mass. So you can see it here. This is like at 78, 79 tons. Also depending on the CG. If your CG is at let's say 6, you're limited to a lighter takeoff weight. Then, for example, if your CG is at 25, then you can take way much more weight. Okay, I'm calling the fuel truck. So we should get some fuel. Okay, fuel is loaded. 5.3 tons. I'm having trouble opening the doors. I am not sure why. But yeah, we could do PA systems here. And yeah, ground tab. We got the chocks on, we got the GPU running, so ground power unit. You can see the the blue light here. Engines are cut off. And now we're going to prepare the flight deck for the flight over to Tampa. So for the cockpit preparation, as you can see, the IRSs are already running. This is how it would look like after maybe a quick turnaround. This aircraft just had arrived here in Fort Lauderdale and going to depart again to Tampa, so not all systems are powered down. That makes it quicker to get the aircraft ready for the next flight. So you just scan the overhead for any lights which are unexpected, and to check if you have to call maintenance for anything, and set up the panel for the next flight. So fuel pumps are off at this stage, including this one. This one is usually left on for the APU, but the APU is off at the time. Here you can check the electricity, and so we are on ground power. So yeah, you see we got 119 AC volts, around 400 hertz frequency, which is standard, and 29 DC volts. All looking good. Drive lights illuminated since the engines are not running. We are on ground power. Those lights should be off if I'm not mistaken, since the engines are not running. You leave the lights off. You can play with the lights as needed for the overhead panel. This is left alone. Emergency exit lights armed. And we are not fueling anymore, so fasten seat belts. You can turn them to on. Wipers off. You would switch this every other flight from left to right. Window heat is off. You can turn it on. And pitot heat, anti-ice off. You got the electric hydraulic pumps off. The engine driven hydraulic pumps, you can leave them on. They only start to run as the engines spool up or running. We got no lights here for the doors since they are, I don't know, not working tonight. Cabin altitude. You can check that this indicates something as expected. It should read 0 on the differential pressure. Yeah, 0 and 0 rate. Yeah, logo light. Some companies put them on, some don't. We're gonna put them on tonight, or this morning I should say. And here the temperature. We're in Florida. People like it cold in the cabin, otherwise you will get a lot of complaints. Recirculation fans, auto. The packs, well, they're pretty much useless if you don't have any air, and without an APU or engines or a ground air unit, it makes no sense to leave the packs on, so you turn them off. So APU bleed to on. You can put the engine bleeds on. And I'm going to check the landing altitude for Tampa. I'm pretty sure it's gonna be really low since there are no high elevations in Florida. So 27. Yeah, it only goes 0 or 50. So yeah, we can leave it at 0. This is to auto. So the overhead panel is done. Then we would start with the FMC. So you start on the ident page. You make sure you have the right model, 737-800. The W stands for winglets. The engine rating. And yeah, I know this is outdated, but in the real airplane, you have to make sure that the database is active. Otherwise, you cannot fly with an old database. So this is for reference. We type in our departure airport, Fort Lauderdale, and we check that the last position and the airport look similar to each other. And the FMC, it guides you through the whole process. So you can see this prompt indicating route. So we hit route, and all boxes are mandatory items. So we fly from Fort Lauderdale to Tampa. And we are Delta Airlines 2514. And in the real aircraft, you could request the route via data link, so dispatch would send you the whole route and you don't have to put in all the waypoints. But today it's not that bad since it is a pretty short flight. So we go departures, 28 left. Let's see what they have. Okay, not what I expected. So the flight plan is filed for 10 left. Yeah, there is no. So my flight plan was scheduled with the B-Nice 2, which we don't have. So I'm gonna leave it on 28 left for now. I'm going to figure this one out later. Let's check. Now we go to route. And then there's only one waypoint in our flight plan. The other points basically are arrival or instrument departures. And it's not in database. Perfect. Okay, I have to figure something else out to get a flight plan that works for us, since the SIBRIEF flight plan uses an active database, and it is of no use since this is outdated. So I'll be back in a minute. So what I came up with is you can create a route here with this EFB, and we're just gonna use those waypoints and connect them to arrival, etc. Although those arrivals, I don't even have charts for the Thunder departure, but we're gonna figure something out here. So the route is Lauderdale Thunder Airway Victor 157 Lima Bravo Victor Tampa. So pretty quick one. So we come back here and we enter the Thunder. Insert it here, then Victor 157 Bravo Victor, and we go to departure, 28 left, and there's a Thunder 4, and for the arrival yeah, 01 right or 01 left. Let's make it easy. It's flying ILS tonight, so 01 left. And I will check the arrivals if anything makes sense. So the dates arrival I have, but they don't make any sense. Yeah, alright, so it's gonna be vectors. Go to route, activate it. And I don't know if this is working. No. Well, route 2 you can set up for your engine failure procedure. Or in flight, you can set up if you expect the ILS 01 left, but there's also a possibility that you can expect the RMP for runway 01 right. You can use route 2, pre-program all of that in there, and in case of a late runway change, you can activate route 2, and you wouldn't have to set up and figure out everything in the last couple of minutes, so that comes in really handy. Then I would go route data, and yeah, winds. That is where you usually would request or put in the winds. That helps with the performance calculation for the aircraft. And then our perf init, we're gonna leave the zero fuel weight, and the gross weight is gonna be empty until you receive your final load sheet. And I'm going to look at my flight plan, and my FMC info says that we need final reserves plus alternate fuel, which is our reserves, 2,436, so 2.5 tons for reserves. And we are cruising at 240. Now the cost index, that is company specific, but my Simbrief flight plan gave me a cost index of 17. So I'll put that in here. Transition altitude 18,000 feet, standard for the US. Alright. And one limit, we can worry about that later. We're gonna leave this page empty at the time. And you can already start to put in your acceleration height, thrust reduction, and engine out acceleration height. This is also company and noise abatement specific. So tonight we're just accelerating at 1,000 feet and also gonna use climb power at 1,000 feet. So this should equal the noise abatement procedure number 2. And yeah, the engine out acceleration height is also performance specific, so you would check in your performance app, and the performance app would give you a number and you put it in here. So this is the earliest you would accelerate after you received suffered an engine failure, and this would be the earliest altitude where you can basically pitch down and retract the flaps. Alright, so cruising flight level 240, our target speed for the climb is 280/Mach 0.76, and we got a general speed restriction of 250 below 10,000 feet, which is standard basically all around the world. Yeah, cruise target 300 Mach 0.8. I think that is a little bit fast for the 737, but we can check that later. Also, flight level 240, most likely we can fly only with a indicated airspeed because it's pretty low. Yeah. What should have happened is that it would delete the Mach number, but yeah, it didn't. Descent speeds are in. We check the progress page. So this is our total distance, 181, and our arrival fuel is calculated to be 2.8, and our final reserve fuel was 2.5, so we have 300 kilos extra if we fly the whole route according to the FMC. We can go to the fix page, put Fort Lauderdale in here with a 25 nautical mile circle. Just for reference, 25 nautical miles, because the MSA, minimum safe altitude around the airport, is always a 25 nautical mile circle, and with that 25 nautical miles, and when you're above the MSA, you have 1,000 feet of clearance to the highest obstacle. So that is quite important doing climb out. So that is why I put this in here. Alright, that is basically it. We're gonna leave this blank until we receive our final load sheet. And this is quite cool. You can actually request an ATIS. So Let's see what the weather is here. This is very important. You need the weather to put in the performance. Also in the ATIS is indicated which runway for departure and arrival is to be expected. And in some instances, there will be notes on taxiway closures, etc. Okay, there we go. There is an ATIS prompt. So we see that at Fort Lauderdale the wind is 090 at 5 knots. Yeah, that would indicate actually runway 10 left. But I'm gonna use 28 left anyways. It's only 5 knots of tailwind and 4 statute mile rain. It looks like clear skies to me. Yeah, 24 degrees, altimeter is 2986. I'm not sure if this is in accordance with what kind of weather I have set here. This might be the real weather, so yeah, it is basically unhelpful as of right now for us. Okay, I'm just flowing through the cockpit. Basically starting here, checking my oxygen mask. Coming up here, I will set my display. Switch this to Baro so I can set the minimums later. Some like to have the flight path vector, it's not indicated yet. And we leave the Baro in inches since we are in the States. And yeah, you can set the range. What I like to do during takeoff, put the range to like 5 miles. And yeah, this is for the weather radar. We're gonna use it later. Flight director on, so the green light for the side for the flying pilot. Arm the auto throttle. FO would put his flight director on, and then we can start setting up with the heading and the altitude which we expect. Since I don't have any charts for the Thunder departure, I will just make something up now. And you would reference this obviously to your chart. So let's pretend that our clearance was to 10,000 feet. So it's set 10,000 feet. And the runway heading is 276. Okay, we got that set. Then we move down here. We check that all of these panels are set and we can do the test. All lights should be working. You can do the light test and you would scan the whole cockpit to make sure that all lights are working. Yeah. Leave this in auto. Brakes RTO. Flap 0, no lights here. We can check the display. This is all looking standard. Low oil pressure, that is normal. The engines are cut off. We have no pressure in the hydraulic system. That is as expected. Brake temperature, flight control deviation looks fine. And yeah, oil quantity looks good. Everything else is 0. So go back to the system page. And we come down here. So speed brakes up, throttles idle, flaps up, fuel control switch is cut off, step trim, we don't touch it unless there's an emergency. Parking brake is on, no lights, nothing popped out of this panel. So you make sure that these engine fire switches, they are down. If somebody would have pulled that one, it would have shut off or will shut off the fuel, hydraulics, electrics, and air for the number 1 engine in that case. So very important. I'm not gonna mess around with the frequencies tonight, but you would set something like delivery here and ground on standby, and you would have 1215, which is the guard frequency. You would monitor this constantly, and you can set up the ramp frequency in here. And then you can set VORs as required. It's going to be RNF transition, so no VORs. ADF, we're not gonna mess around with it. And yeah, you can monitor. So we are transmitting on number 1, so this is this frequency here, and we want to listen to number 2. And yeah, make sure that the rudder trim is 0. It is 0. And the FO will set up his panel. Transponder on standby, set to 1. And yeah, let's pretend that this is our squawk code. You will get the squawk code with the clearance. And yeah, no lights here. And the weather radar is not functioning in this model. So that is it for the initial setup of the cockpit. So boarding and fueling is all complete. We would have received our final load sheets, and then we would put in the numbers for the 0 fuel weight, and the aircraft already senses the fuel. So if you put in the 0 fuel weight, it will add the fuel weight and will give you the gross weight. And you would check this according with your load sheet and make sure it's the same number. In the flight sim, you can just hit the key here and it will automatically put the 0 fuel weight numbers in there, so you don't need a load sheet or anything. That makes it quite easy. But I'm going to check the numbers with my flight plan. So 0 fuel weight 54.2, that looks good, and the gross weight is 59.5, and our takeoff weight is 59.2. And let's see if the taxi fuel most likely is going to be 300 kilos. Yeah, it's not. Oh yeah, the taxi fuel is 227, so that makes sense. So we can execute it. Yeah, usually you don't have to execute the weights, but in case the execute light illuminates, both pilots would have to confirm it before you execute it. So we got the weights in. Go to the N1 limit, and we can select the D-rate, also company specific. So we can derate the engines to 24K instead of the full 26K. And we can also use climb 2, meaning that the climb power is reduced. If we have the performance for it, this serves engine life. So basically, if you use less power, the engines will be running longer. You can use them for many more years if you would always blast out with full power. So 24K D-rate, our N1 is 94.3. We have calculated flaps 5, the CG 24.4 now, and the sim gives us the speeds automatically. That is very nice. So you don't need any performance app. The FMC here in this sim will tell you all the data. So V2141, this is what we set in the speed window. And we put the VNAV into ARM. We leave the LNAV. Oh no, we have departure, so we put LNAV, VNAV both in ARM. And it should give us the flight directors. So it says flight director, but there's no flight director indication. That is weird. All right. so we got the MCP set. We got the weights. We can now close the cockpit door. Boarding is complete. And we can start the APU. So you hold it in start for like 3 seconds. And then the EGT should rise up. And as soon as the APU is powered, we get a blue light indicating that we can put the APU onto the generator. Put the fuel pump on, and there we go. EGT is rising. All right, blue light. We can put the APU on the bus. APU is now powering the aircraft. And we can also check here, APU generator, and all the numbers look good. We can tell the ground guys that they can disconnect the ground power, and then we can start requesting our pushback. Also make sure that all doors are closed, all stairs are, if you have air stairs, retracted, and then you can get going. So parking brake is set. We'll just remove them. APU is running. All ground equipment is clear. So now we can proceed with the pushback. Okay, so we go to better pushback, pre-plan, and I want them to push us like this. So I'll set it.
Plan acknowledged. Call me through the menu when you are ready.
Okay.
Ground to cockpit. Tow is driving up.
So tow should be driving up any second. There we go. And now we wait until they connect. Then they would give us the signal that we can pressurize hydraulics. We would read the before start checklist, get the clearance from ramp or ground, whoever is responsible for it, and they would issue us a pushback clearance. Driving up, they should lift us up.
Okay, all doors and hatches are closed. Ready to connect.
And they have to confirm that everything on the outside looks fine. No latches are left open. All doors are closed. Because the fueling panel could be open and there's no indication in the cockpit. So they have to tell us that all the little hatches on the airplane are closed. Now we're being lifted. You can see it. Our airplane is slowly rising.
Tow connected and bypass pin inserted. Release parking brake.
Okay, we're releasing parking brake, and he said that the pin is inserted.
And you may start engines.
All right. So important for us, and the first thing is that he told us that the pin is inserted, so we can pressurize all the hydraulics. So we put the fuel pumps on, we put the hydraulic on, and we will put the anti-collision light on. The packs are off. We have duct pressure. And now we can start the engines. We would then tell the ground guys that we're starting engines 2 and 1 in sequence and that we're starting number 2. Then the captain would communicate to the first officer starting right engine. You would turn this to ground and we would have the engine system up here. So engine start valve open and we see the N2 spooling up. And around 25% I will put the fuel to idle position. So put the fuel, you can see fuel flow, EGT is rising, and now we just monitor that we do not get a EGT temperature exceedance. If it would approach the red bar, you would have to cut it off manually. That is one of the memory items during engine start. And 56% N2. The start lever
Operation complete. Set parking brake.
went back to auto. Okay, parking brake is set.
Disconnecting tow. Stand by.
They're disconnecting and we're gonna wait for the signal on the left or right side. And we're gonna start engine, we're gonna start the left engine. Okay, so we had an issue with the left engine because the fuel cutoff switch was out of cutoff and I didn't notice, so that is why it didn't start. But now N2 is driving up. Oil pressure light is off, 25%. Put it to idle. Fuel flow, EGT, we monitor. And at 56, the starter should go back to off. And here you hear a click. And it's back to auto, sorry. We got 2 good starts. Put the system page back on here. And we would have to put both engines onto the buses. So now you see this is illuminated, meaning that the APU is still available, but not on bus. We can shut down the APU, put them to continuous, put the packs on, bleed on, APU bleed off. And hit the recall. So you hit this for the recall, you want it to be out. If it would be illuminated with the master caution and any of the messages, you know you forgot something or something is not working correctly. So now we wait for the guy with the pin, and if he shows us the pin, we can do the before taxi checklist. Alright, he just told us that hand signal on the left, he's driving away. Okay, pushback is terminated. We see the guy with the pin. Perfect. Then we would go flaps 5. And we could do the flight control check. So full up, full down. And we monitor the deviation here on the system page. Full left, full right, neutral, and the rudder. Full left, full right, neutral. All right. So we leave that blank. We have the most important engine readings over here. Flaps 5. APU is off. And now we can request taxi. So taxi lights on. And we would request taxi. And then both pilots would confirm clear left, clear right. And we would get moving. Or at least the parking brake. So before turning into any taxiway, usually the captain is taxiing, he would tell the FO, yeah, I'm turning left here, and the FO would confirm it, and also you would check clear left, clear right, that there is no traffic. So you can see on the windsock over there that the wind is calm. During taxi and when you are clear of any ground personnel, you can put the weather radar to on. And on the ground, you steer the aircraft with the tiller, that is this thing. So I can move it here, left and right. You wouldn't really use the rudder pedals because they only deflect to a certain number of degrees. And the tiller deflects to a way higher nose gear deflection. So for tight turns and on the ground, you use the tiller. On the runway, initially you can use the tiller, and then you would use the rudder pedals to keep the aircraft on center line. And we're taxiing, and as soon as we are going in a straight line, we can do the before takeoff checklist. And on the way to the runway, you can also perform a takeoff review, telling the other pilot V2 is 141, initial heading 276, we're climbing 10,000 feet altitude. It's a flaps 5 takeoff from the left-hand seat. No speed restrictions other than the usual on the departure. And in case of engine failure, we would go straight ahead. Acceleration would be 1,000 feet, something like that. Then we would do the before takeoff checklist, so configuration, I'm not sure what they mean with that, but flaps 5 green light, stab trim 5 units, takeoff briefing reviewed, cabin, yeah, you would have called the flight attendants and tell them prepare for takeoff, so cabin secured, MCP is set, transponder, so yeah, this part here we would do after lineup. So this is a weird checklist, but I guess the dashed line means this is the first part and this is the second part of the checklist. And we're about to reach our lineup point at Juliet 12, runway 28 left. And if the tower already cleared us for takeoff, we would put the lights on, runway turn off lights, put the strobe lights on, transponder to TARA, and then we can read the takeoff checklist below the line. So MCP is set, transponder TARA, strobe lights on, landing lights on, before takeoff checklist complete. So would make sure that nobody's on final approach or on the runway, and we can actually line up. We see the sign, runway 28 left identified, cleared for takeoff and lineup. And we would check the heading as soon as we are lined up on the runway to confirm it again that we are on the correct runway. This is very important, especially during low visibility operation. You really want to make sure that you're departing from the right runway. And you would have seen the numbers in the real world because you have a better view than out of this here. And there we go, heading 276. That looks about right. And then you would ask your pilot monitoring if he's ready. Put the engines to 40%. Let them spool up. Hit the timer. Okay. I guess this adjusted our takeoff power. So now N1 toga. Thrust set. That is cross-checked.
80 knots.
That is checked. Throttle hold. Now you use the rudder pedals to keep it on the runway.
V1 rotate.
And we rotate off the ground.
Positive rate.
Gear up.
400.
Checked. And I have no idea why, but it kicked out of my LNAV and VNAV.
1000.
1000 is checked. So N1 LNAV VNAV speed and command. So now we're on autopilot. And we should start with our acceleration here shortly. So now the green arrow is moving towards the 1. And when we are certain that we're going to reach the flaps 1 speed, we will put the flaps to 1. We are accelerating towards our up speed, so flaps up. And the flaps are driving up. And the after takeoff checklist after flaps are up. So auto brakes to off. Landing gear off. And you can put the taxi and turn off lights to off. And both ignition switches to auto. We accelerate to 250 knots. And after takeoff checklist. So air condition and pressurization is set. Forgot that on the ground. So we're cruising at 240. And engine start switches off, auto. Landing gear up and off. Auto brake off. Flaps up, no light. And altimeters are to go. So after takeoff checklist complete, 1 item to go. Okay, if they cleared us to flight level 240, we would set 240. Then one pilot would call 240 set, the other one would check and confirm it. And we are climbing. Pretty good climb rate. Maybe some of the real 737 pilot can comment if this is realistic with a takeoff weight of 59 tons. And now we're waiting until we passed 10,000 feet. Then we put the lights off. Alright, 10,000 feet. Landing lights off. We give it a good look on the overhead panel. If there are no lights, that is good. So no amber lights, no red lights. We're accelerating to 286. And on conversion, we're gonna climb with Mach 0.75. So as soon as we see Mach 0.75 here on the Mach reading, it is going to change to Mach 0.75 over here. I don't know if we're gonna make Mach 0.75 in a climb out because we're already stopping at 240, which is pretty low. But if we would have climbed all the way to like 380, at some point we would switch over to Mach 0.75. Yeah, also check the fuel after takeoff. So we burned roughly 500 kilograms. You can have a look at the system page. All looks good. Secondary engines, all within limits. And we're about to pass 18,000 feet, which is the transition altitude. You see it here, magenta box. So altimeter set standard, and then the other pilot would call out standard set, passing flight level 186 checked. And then we can do the rest of the after takeoff checklist. Altimeters are set and the after takeoff checklist is completed. Okay, so we're gonna set up the ILS frequency. We also are at our cruising altitude or flight level 240, and like I said, we're flying indicated 292. Yeah. And yeah, so I'm setting up the frequency. Let's see how I will manage this. So this is in VOR mode. Yeah, we have to switch the mode. So yeah, ILS, GLS, whatever, they got everything. This is the new panel. So 1089. So this is active, and we could also set up a VOR like 116.4 on standby for the missed approach, which is St. Petersburg. So now we got the ILS, and we need a final approach course. Here it is telling us 007. The same I have on my approach plate. So 007, you would set it usually on both sides, especially if you want to fly a Cat 3 autopilot self-flown approach. And yeah, auto brakes, just put them to 3 as of right now. And yeah, then we check the progress page. So arrival at Tampa with 3.5 for now. And yeah, we have not connected this. So yeah, execute. Yeah, so this is one line. So now we should get a better prediction of our fuel. So 3.3. And we have 4 tons in the tank, so minus 700 kilos. So 58.2 minus 700, 58, so 57.5. That is our expected landing weight. And it's gonna be a flaps 30 landing, so we're going to paste the speed in here. So the speeds are set. I will check on my chart. Cat 1 minima is 210 baro. I'm not planning on a auto land. With a real low visibility, you would set the minimums using radio altitude. And the approach has to be certified, the crew has to be certified, the airplane, blah blah blah. That would be a whole nother video to talk about low visibility operation. So Baro 220 set, both pilots would set it on either side. Yeah, excellent. So we got the frequency, got the speeds, we got the brakes. And yeah, we could do our descent briefing or approach briefing. So it's gonna be pretty much from this point here into Lagu, and from Lagu it is Selman, runway 01 left. This is for the missed approach above 500 feet, and we're turning to St. Petersburg VOR, yeah, with a heading track 226, climbing 3,000 feet or above. Alright, yeah, and then the holding 3,000 feet or above at the VOR. So, and actually my chart tells me at 2,000 feet. So we have to do a slash and 2,000. And the same goes for the holding. And the other pilot would confirm it and execute. And yeah. So final approach speed 139 plus the wind speed. Winds are calm, so plus 5 knots, 144. You can put in for reference 144 for runway 01 left. Execute that. And yeah. Center the heading. So approach briefing. So ILS 01 left. Frequency 108.9. It's checked and confirmed. Final approach course 007 set 2 times. Platform altitude 2,600 starting at Selman, 9.9 miles from the localizer. We're descending down to minimums 220 feet. And in case of go around, it will be 500 feet or above. Then a left turn climbing 2,000 feet into St. Petersburg. So 2,000 feet is a threat that is very low. So we have to monitor low alt capture and make sure that we do not overshoot the 2,000 feet. MSA is 2,700 all around the airfield. Also a threat since the go around at 2,000 feet is below that. So we strictly have to adhere to the procedure to not be out of the holding area since the MSA is higher. After landing is 01 left with auto brakes 3. Most likely we can vacate Whiskey 556, and then we're going to taxi to our gate via Victor, and yeah, we will see. Alright, fuel upon arrival is 3.2, and our CMR or reserves is 2.5. So we have 700 kilos to burn. That would be for a quick go around. Then you would ask if the other guy has any questions. If they don't have any questions, you can do the descent checklist. So descent checklist, pressurization, landing altitude, 0 feet set for Tampa is checked, anti-ice not required, minus 11 degrees, and there's almost no clouds. Approach briefing and fuel discussed, and speed bugs and altitude bugs are set. Descent checklist complete. We'll do a recall, no light illuminated, that is good, so we don't have any issues with the airplane. What we can do is we can put a fixed page for Tampa now. So Tampa, 25 nautical miles for the MSA circle. And yeah, some people also put a ring for our descent. So we're cruising at 240, you multiply it by 3, so 20 times 3 is 60, 4 times 3 is 12, so 72 miles, and we have to slow down, so roughly 10 more miles, so 82 miles could be a good indication to start the descent. And we are already past that. The aircraft is telling us that we should descend over here. Let's see the progress page. So 61 miles. Yeah, we're already late to descent. So let's see if we can get this done. So descending flight level 10,000 feet for now. So 10,000 feet. We're going flight level change. And it says retard MCP speed. So throttles are going back to idle. And if I spool up the speed, what should happen is that our descent rate will increase. You can see it here, since flight level change is a pitch mode and it is pitching to hold our airspeed. And we're descending and we commanded 310 knots, so now it is going to descend faster as if we would have descended at 290 knots. And we're cleared down to an altitude 10,000 feet. There's no flight level restrictions, so altimeter set QNH. QNH 29902 set passing 21,200 feet now, and that is cross-checked. And let's commence further descent down to 5,000 feet. So I'm also monitoring my green banana. This means this is the point where we are going to reach 5,000 feet. And there is, what's that point called? Lagu at 2,600. So, and my VNAV also indicating that we are very high. So I will use some speed brakes to get down there. So now my green banana is indicating that we're going to be at 5,000 feet, somewhere around here. And we're closing in onto our VNAV path. So now we're 6,200 feet above our profile. Yeah, that's not where you want to be in the real world. But this is a sim and we can play around. And actually 4,300 is still acceptable as a descent rate. It's not ideal, but it is nothing the airplane cannot handle. And we're closing in the VNAV path. That is good. Good for reference. And we're closing in on 10,000 feet. So I have to think about reducing the speed since it is 250 below 10,000 feet. So I have to reduce to 250. And now you can see the airplane is pitching up because it is using pitch to control our airspeed. And the only way it is able to reduce that airspeed is to pitch up the nose. And I still have the speed brakes extended just to get down faster. We might need some vectors since we are really high. Still 2,600. Yeah, now it's increasing again because we're reducing our speed. And with a reduced airspeed, our descent rate is also smaller or decreased compared to a high airspeed like I talked about before. Okay, as soon as we have 250 on the airspeed, the airplane is going to pitch down again and maintaining that airspeed. And it looks about really nice. 250, 10,000, so no airspeed busts. And 10,000 feet. Put the landing lights on. So flight level change, that means I control the speed. In VNAV, there's two modes, VNAV speed, VNAV path. VNAV path, the airplane is following the calculated VNAV path. in our case, our calculated VNAV path is 2,400 feet below us, so we are still high. And if I would be on VNAV and we would intercept that path, it would catch the path and it would go from VNAV speed to VNAV path. At least that is how it is in the 7.5. It is, I think it is similar here in the 7.3. The names might be a little bit different, but I think the principle is almost the same. Like Boeing logic is spread across all Boeing fleets, and it's similar to every Boeing aircraft. Okay, descending now 2,600. And yeah, that looks good. We are within 25 nautical miles. MSA is 2,700, so we have to monitor. Also, we are visual. That helps with checking terrain. In low visibility, you would have to cross-check your chart, check the terrain here on the display. But I'm gonna stick to the weather radar. There's only one thing you can use. It's either weather or terrain. So when there's high terrain, one pilot would use the weather radar, the other pilot would use terrain. And checking the distance on the progress page. So 22 miles, yeah. Can slowly start 2 degrees. And yeah. Let's see if we're able to pull this off. And Selman is our descent point. At that point, we have to be at 2,600. So yeah. We can also use drag to get down quicker. So we have the flap limit speeds indicated here. So flaps 1, 250 knots. We could go flaps 1. Building up drag helps increasing the descent rate. What helps the most is the landing gear because it produces the most drag. But it is way too early to put the gear down, so we're not going to do that yet. I'm gonna leave the speed a little bit higher. We could turn it down to flaps 1 speed, but that would reduce our descent rate. And yeah, we're looking good for the profile. I go back to flap 1 speed and I will go into vertical speed. And now I can place my banana onto Selman. Yeah, something like that. So we have a continuous descent. If we were cleared for the localizer, we can hit the localizer. And you see viewer our loc is armed. White modes means armed. Green modes are the engaged ones. Yeah, checked. We got 13 miles to go. And we're looking nice on profile. Nice on the speed. And we can retract our speed brakes, of course. So you can see the localizer moving in, localizer captured. And just heading to final approach course. We can go flaps 5, flaps 2. This is confusing. In the 7.5 we don't have flaps 2, and we go flaps 1, flaps 5. So an additional flap setting here in the 737. So Alt acquire And we can hit the approach mode, glide slope armed. It says single channel, meaning as of right now, no auto land. Alt hold, and we should get the glide slope here in a second. And I'm being very conservative with the speed. We're at 160 knots. And I'm not sure why he's doing a bad job at holding the speed. So glide slope is captured. And if I switch to approach, we get this view. But you can also leave it in the map mode for better visual reference. You have your ILS markers here, glide slope and localizer. And we got the distance over here, so 8.8 miles till runway threshold. Or basically the localizer antenna, not really runway threshold. So this is a radio altimeter 2000 feet in the 7.5. The gear would have already been down, but in this airplane I don't think it is that critical. So I'm going to wait for like 6.5 miles and then I will drop the gear. And we put them to continuous. And if we're clear to land, we would put on all the lights. Okay, let's go gear down. Flaps 15. Put the speed down to 15. And we're approaching flaps 15 speed. We can go flaps 25. And our speed, final approach speed 144. Arm the speed brakes and we can do the landing checklist. We forgot about the approach checklist. Alright, landing checklist starts, which is continuous. Recall checked. Speed brake armed, green light. Then we have landing gear down, green light. Flaps 30, green light. Landing lights on. Landing checklist complete and we're past 1,000 feet. We are stable. I am visual with the runway. And now we can try to land this airplane. Alright, so I'm disconnecting the auto throttles. And I will adjust this here so we don't get any surprises. So, manual thrust and autopilot off. I'm getting high and I'm correcting. And we are visual and passing the minimums. So now I'm going to aim for the touchdown zone markings. I'm a little bit fast. So I'm looking on the white markings on the runway. And now I will look outside to the end of the runway. Close the thrust levers. And we're floating. Excellent. Touchdown. And we could go to reverse thrust. Manual braking.
knots.
Checked. Okay, and we're going to exit here. That is seems to be Whiskey 5 as we planned. And turning off the runway. Crossing the bars. And yeah, so Whiskey 5 Going to Victor 5. And I'm going to slow down so that we can do the after landing flow. So let's make sure that we get the APU running. Speed brakes up. Let's put the flaps up. Okay, this is oversteering. Auto brakes off. Put the flight directors off. And doing this single pilot increases the workload immensely, so the FO would do all the stuff here and put the trim back to a neutral setting. Alright. And we're already left of the center line. And now we taxi to the gate. The FO would now call ramp. Make sure that the gate is available. Going to turn here into the next gate. You would wait for the marshaller. In case there is no marshaller to guide you in, there would be a guidance system. It's a display and would read something like Boeing 737, maybe your flight number, and it would tell you you're left of the center line or right, and how many feet or meters you would have to continue until you would have to stop. And we set the brakes. Parking brake. APU is running. We connect the APU. That should be to auto after landing. And you would turn off all the lights after landing as well. That is why you have two people. And now you can shut down both engines. Do the shutdown flow, fuel pumps off. Put the seat belts to off. Anti-collision light off. Leave the packs on so the people will get air. Alright, and we're back at the gate. they would put the chocks on, get the GPU, and yeah, let's extend the stairs. Maybe we can open the doors this time. Oh yeah, now we go. Now we can do it. So forward entry door, and yeah, open the cargo doors. Yeah. Then we can switch to ground power. So now the APU is off buzz. We can put the packs off. And we can shut down the APU. Put the fuel pump off. And yeah, transponder should be to standby and 2000. And if you want to shut it down completely, you would turn the IRSs off. Then you can put the emergency exit lights to off. Alright, window heat off. This is off. This is off. Doors are open. And this should be off as well. And looks like the APU has shut down completely. Then you could take the battery off, all according to the checklist, of course. And now you leave it on the ground power. And then you can go on home to your next flight, whatever it may be. I appreciate you watching this video, and please hit subscribe and like. Put in the comments what you want to see next. Maybe what kind of airplane, maybe a special video on some special approaches, FMC tutorial, whatever it may be. Please comment, and thanks for watching.